Good morning, good afternoon, and good evening, and welcome to our webinar, Outage-Proofing Your Cloud Applications. Today's webinar is, of course, about outage-proofing your cloud applications. We'll start off by level setting on a couple of critical concepts that you need to know. We'll show you how to design for failure. We'll show you a couple examples of disaster recovery setups that you can choose based on your uptime requirements, and also just share some general best practices for outage-proofing. But before we get started, we have a few questions that we'd like to ask you. So with that, I'll launch my first poll question. This is a simple question. Where are you in the cloud adoption process? Just select the one that's most applicable. Are you just getting started, just learning? Maybe you have a little bit of cloud usage, you have some cloud credentials, and you're starting to go mainstream, maybe one or more apps across your company. Perhaps you have broad usage, but you're still working on finessing your processes. And maybe you're an expert and you're here to learn more. So we'll leave this open for a couple more minutes. Just kidding, a couple more seconds. That'd be very dull. Okay, let's go ahead and push the results out. Okay, interesting. So there's kind of an even distribution across the audience, but it seems like most of you do have broad usage across your company. So that's really interesting to know. Thank you. Second question. Yes or no, have you been affected by a cloud outage? There have been a number of them throughout the years. If you've been affected by one, please select yes. If you haven't, then that's great. Leave this open for a couple more seconds. Okay, push it out. Oh, I'm sorry, guys. It looks like 60% of you have been affected. You'll learn some good tips and tricks this day. So next question, two more and then we'll be done. So for those of you, that's 60% who have been affected by a cloud outage, how much downtime did you experience? Was that less than 1 hour, less than 5, less than a day, or was it more than a day? And we'll leave this open just for a few more seconds since it doesn't apply to everybody. Okay, it looks like for about the ones who were affected by an outage, most of you less than a day, and of those, most were less than an hour, so that's awesome. I'm sorry for the ones who were more than a day. We'll leave this open for one more question, and then we'll move on. Okay, we're really curious. Which outage-proofing strategy are you considering? So check all that apply. And the reason why we're asking this question is because we're actually covering a couple of these options, actually we're covering all of these options in today's webinar, and for if there's one in particular that more people are interested in, maybe we'll spend a little bit more time on that. And the last option is just a little flip-in. It just means that you would like to learn more. You don't really know which one's the best fit. I like to have fun when writing these questions. Okay, let's show you the results. Okay, it looks like most of you are interested in multi-region. A lot are interested in multi-AZ and HA. So cool. With that, let's move on with the webinar. I'd like to introduce the speakers with me today. I have Brian Adler. He's RightScale's Senior Professional Services Architect. Brian works with customers from small startups to large enterprises, and he helps to bring any of their legacy or new applications to any cloud or combination of clouds supported by RightScale, whether that's public cloud, private cloud, or hybrid. So Brian's been exposed to many use cases and applications and is an awesome resource here at RightScale for our customers. I'm also joined by Roberto Monte. He's a cloud solutions engineer at RightScale. Roberto works with customers in the pre-sales stage, so he helps them evaluate workloads, decide where to put them, and figure out which cloud's the best fit. But there's also a really interesting story about Roberto. So he has the ultimate outage-proofing story. He helped CNN.com stay live during 9/11 when millions of people worldwide otherwise brought CNN.com to its knees. He managed a pool of gaming servers over at Cartoon Network, and those servers were quickly repurposed to handle some of that heavy CNN.com load. So that's pretty interesting. One quick housekeeping thing I'd like to point out about GoToWebinar is the questions section. So check it out in the main GoToWebinar question panel. Spencer and Noel, account managers at RightScale, are standing by to answer those questions as they come in. But throughout the course of the webinar, we'll be monitoring those questions. Anything that's really generally applicable to the majority of the audience. Brian and Roberto will answer live on the air, so make sure you ask your questions early and often. Make sure you get them in. I expect there will be a heavy flow at the end. That'll be a pretty exciting live Q&A. Hashtag for this webinar is RightScale, so join the conversation on Twitter. One final housekeeping thing, if you happen to have problems with audio during the webinar and you're on VoIP, if you could please shut down some extra applications. We've found that that can put a heavy demand on the CPU, so just shut down extra apps if you happen to have audio issues. And with that, I'll hand it off to Brian. Thanks.
Thanks very much, Sarah. And I just want to extend my welcome to you all as well. Thank you for joining us today. As Sarah mentioned, I'm an architect in our services organization, and in that role I've talked to, by this time, hundreds of customers. And probably one of the most common themes that I talk to folks about is what we're going to be talking about here today, and that's HA and DR. Particularly in the last few years, right, we started to see more and more of these cloud outages that started to bring it more to the forefront of people's minds. And I've spoken at a few community events, some RightScale events, some AWS events, and some cloud expos. And this is the topic that always comes up. So what we've done here today is try to capture a lot of those previous content that we've used and get the tips and tricks and best practices around setting up some HA and DR scenarios that we'd like to share with you all today. Sarah briefly touched on the agenda earlier, but you can see it here. Basically, we're talking about HA and DR, all things HA and DR, and then we'll have some time at the end for questions. I do want to talk a little bit about terminology. I generally like to just make sure that for the next 45 minutes we're using the words that mean what we think they mean, right? There's a lot of words mean different things to different people out there, and like I said, these aren't necessarily the de facto definitions, but at least that'll be a working definition that we can use for the rest of our discussion here today. We'll then talk a little bit about designing for failure, and what does that mean? Well, you know, parts of your app and your infrastructure are going to fail, so we've got to talk about how to design around those and mitigate the risks that come with those. Then a little bit on cloud and component definitions. The clouds have different words for the same things and different words for different things, so we want to talk about each of the providers, at least the bigger providers out there, and what they provide to you and what those components are named and how we see them here within RightScale as well. Then we'll talk a little bit about HA, and then Roberto will do some DR stuff. And then we'll have just sort of a wrap-up of sort of a summary of what we discussed. And then, as Sarah mentioned, if you guys have questions throughout the webinar, please feel free to enter them in that question window. We got a bunch of pre-submitted questions, so thanks to all of you that did submit some ahead of time, and I kind of took a look at those last night. The vast majority of those we're going to cover through the content here today. So at the end, if there's anything that's still pertinent that I feel we haven't touched on, I'll be sure to answer those directly. But please do enter them as we go along, and if there's anything that's relevant to the topic we're currently on, we might break and answer that question. Otherwise, we'll try to tackle them all at the end. Okay, terminology. Just real quick, sort of the first three that I like to talk about. The first one is fault tolerance, and you can read the words here. Basically, ability of a system to continue operating properly, perhaps at a degraded level, if one or more components fails. Basically what that means is that something's going to fail in your application, something's going to fail in your architecture, and your fault tolerance is how well you can handle that, right? You might continue to operate at a degraded level, and that's, you know, maybe fine, but the point is that you haven't gone completely down when a single component fails. Basically, no single point of failure, SPOF, if you see that in the literature. The next one is HA, high availability. Fault tolerant systems are measured in terms of their HA. Anytime you hear people talk about the 3 nines or the 5 nines, or S3 has 11 nines of durability, which is ridiculous, you know, those things are all in terms of the availability of that service that's being provided to you. Now, the important thing is to remember that includes both your planned and your unplanned outages, right? So if you have a planned maintenance window, that also counts against your availability score. And then the last one is disaster recovery. Basically, the process that you have in place to get yourself back up and running in an unaffected environment when something catastrophic happens to your primary environment. And we'll talk a little bit about each of the options there. Actually, Roberto will talk about those here in just a little bit. Okay, so next one is designing for failure. And sort of 4 bullet points that we like to talk about. The first one is that large-scale failures in the cloud are rare, but they do happen, right? They've started to become more and more public, if you will, as more and more folks are getting onto the cloud and starting to use it. The first real big one was probably back in May of 2010. The one that affected a lot of people and kind of had the most press was there was one in April of 2011, but just in the last 12 months, there's been a few as well. And like I said, they are rare, but they do happen, and more importantly, they will continue to happen. So number 2, the owner of the application, you who are providing this application to your end users, you're ultimately responsible for the availability and the recoverability of that application. The cloud providers are giving you a great tool set. They're giving you all these tools to build these really cool applications and architectures. You need to use them wisely. The analogy I always use is that, you can have the greatest tool set in the world, but if you're a crappy carpenter, the first big wind that blows is going to knock your house down, right? So you need to make sure that you have the skills, or you find people that have the skills to be able to build what you need given the tool set that's been provided to you. Number 3 is really about insurance, essentially, right? You need to balance the cost and complexity of the HA that you want to implement against the risk you're willing to bear, right? You're basically setting up in some environments and paying for some environments that you hope you never use. So just like with auto or home insurance or whatever it may be, how much am I willing to spend versus how much am I willing to risk might happen, kind of thing. And then the 4th bullet point is sort of the happy bullet point on this slide, which is that the cloud providers have made DR and HR remarkably affordable, right? You can have multi-server configurations, multi-zone, multi-region, and multi-cloud configurations, and you can spin those up in a matter of minutes. When else in history have we had that ability to have those sort of resources available to us in that short of a time frame? Okay, now this one here, what we're trying to show here in these tables are sort of the what we call the cloud isolation definitions, but more so just the different providers, what they provide and what they call these things, and then also how they present themselves. You might be aware of how they present themselves and you might not be, for example, like an API endpoint, things like that. But basically what we like to say here is that the region is one or more, it could be a single one, and for example, the case of Rackspace and Windows Azure, it's sort of that way, one or more geographically proximate zones, all right? And a zone is then a data center with separate power source, separate cooling, and separate networking that resides within that region. So again, a region can be a zone, or a region can have multiple zones within it. The API endpoint, anytime that you launch a server or you query about volume status or whatever it may be, you're making an API call to an API endpoint that's provided by that cloud infrastructure provider. And for both the region and the zone, those are shared. So for example, in AWS US East, there is one API endpoint for US East, but that also controls and dictates the behavior of all of the zones within US East. And similarly with the local area network, and that's shared as well. So if you're, again, in US East or US West or whatever it may be, you're presented with a 10.x.x.x network, that is shared within the region. It's not shared across regions, but it is shared within that particular region. Okay, and then the second part of the table down below, we've tried to show some of the primary providers and sort of how they break these things out. And AWS kind of came out with the concept. They were obviously the leader in the market, so a lot of folks have followed that along just because their nomenclature and their architecture has sort of become de facto, at least well understood. So you see here that AWS has the concept of regions, like we talked about, US East, US West, EU. I think there's 9 total if you include the GovCloud at this point. And each of those regions has at least 2 availability zones within it. Rackspace currently presents a region and a zone. Essentially is the same thing. There's Rackspace in Dallas and Rackspace in Chicago and Rackspace UK, etc. Windows Azure currently has 6 different regions in their technology preview. When they go to GA, that may change, but currently a region also presents itself as a zone with Windows Azure. Google Cloud Platform is a little bit unique in that they have a single region. Essentially, it's a single API endpoint, but all of their availability groups or data centers are within that single region, but they're all around the world, which is a little bit unique to their architecture. And then CloudStack and OpenStack, it was hard for us to really define these exactly because they're so variable. You can go ahead and set up your own CloudStack environment and your own OpenStack environment, and you can set up regions and you can set up zones, but if you don't have different power and cooling and networking, then you really can't. So the point here is that you can set them up this way, but again, it's up to you because that's infrastructure that you own and that you can control. Okay, excuse me. So what we have here now is what we generally recommend to customers when they come to us and say, hey, I want a HA environment. I want to get myself set up so that I can increase the availability of my application as best as possible. And we'll kind of walk through this here, but the example here that we've shown is in AWS US East 1A, and on the right you'll see AWS US East 1B. So this is a single region, and we're using in this example 2, but just for the simplification of the diagram, we've only shown 2 availability zones, but we would recommend you do this in all availability zones that are available to you within the region that you have selected. What you'll see is that you have at least one of each component in each of these availability zones, right? So you see that you have at least one load balancer in each AZ. You've got your application servers auto-scaling across all the availability zones of the region. and you've got your master in one AZ and your slave in another, right? We recommend that you place the slave database in a different zone for failover. So, for example, in this case, if US East 1B was to go down, you would definitely suffer some performance degradation on your application, but your app would still continue to function because your master is still available. You could scramble behind the scenes to relaunch a slave and get everything reconfigured, but your application as a whole would continue to perform. It would be fault tolerant in this regard. If you lost US East 1B, you'd have a little bit of downtime as you scramble to go ahead and promote the slave, which is in US East, if you lost US East 1A, apologize, you would lose your master, but you would be able to promote the slave that's running in US East 1B. So you'd have a little bit of downtime as you went ahead and did that promotion. We always recommend that you snapshot your data volumes, right? You always want to take backups as frequently as you can so that you can go ahead and stand back up that database in that same region. Amazon just recently, actually this morning I believe, announced the ability to go ahead and copy snapshots from one region to another. Until today, that was not previously available. So they've made things a little bit easier, but the same concepts are still applicable. You want to go ahead and take those snapshots and put them up to some persistent, redundant storage so that if bad things happen, you have your data saved somewhere. What we recommend to some of our customers that are really worried about HA is consider local volumes, local storage, the ephemeral disks, if you will, for your slaves. Many of the AWS outages have affected primarily and sometimes even solely the EBS backplane, for those who are familiar with the elastic block storage. And most databases are implemented using that EBS service. If you want to insulate yourself from that, you can go ahead and set up a slave that's running purely on ephemeral storage. And if there is an EBS outage, that slave won't be affected. You can promote it to master and continue to function until the EBS issues have been resolved, and then you can go ahead and move yourself back on an EBS-based master-slave configuration. And sort of lastly, we recommend, where applicable, where you can do it, NoSQL solutions. You can go ahead and spread those nodes of a NoSQL solution like a Mongo or a Cassandra or Couchbase or whatever it may be across all the different zones and really set yourself up to be highly resilient and highly available in terms of using the replication factor built into those technologies so that if you lose an AZ, you don't even need to do any promotion. You've got enough replicas in other AZs that your app will continue to function and no data will be lost. So this is sort of in a nutshell what we generally recommend to customers when they're looking for purely an HA standpoint. What we're going to talk about next, I'm going to pass it off to Roberto, and he's talk a little bit about the disaster recovery or DR options that we have.
Thanks a lot, Brian. Really appreciate that. So this slide attempts to show the relationship between your uptime. So if you want 99.99% uptime, then a multi-cloud HA option would be the ideal. But since most of us have budgets, we have to kind of make some trade-offs there with costs. So something that might make sense in terms of a multi-cloud HA situation would be something like the stock market. Where it needs to be close to, let's say, New York, and for most of the time. But in case of a regional disaster, let's say a Sandy, then you would want to have a live configuration ready to go. So I also, as was stated earlier, I worked in Turner Broadcasting for about 10 years, working on different projects from gaming all the way to the news. So another, situation where you'd be willing to make that cost trade-off and complexity would be at something like CNN.com. Moving down the scale, we just look here at a hot DR option. So this option would have everything running, but not the secondary DR site not necessarily taking live traffic. And this is, it's not too common, again, because of the costs. But again, a banking type situation might be something that would warrant something of that sort. We do see a number of people, and we recommend a warm DR. And this could be something like a core component, let's say a Cartoon Network, their game, or something that you just cannot take very much downtime. But you also couldn't spend as much as you would for, let's say a banking system. And then finally we get down to the cold DR, which we see quite often. This could take, in order to bring it back up, it's going to cost you less money, but it could take over an hour to enable the disaster recovery option on here. And we'll continue to talk a little further on each one of these here. So here we go into the multi-region cold DR. So what you see here is it's in rack space. We've got two different regions here, the Chicago and the Dallas region. And you'll notice that the kind of white grayed out Dallas zone is not running live. So it's been configured, so it's been staged. You've got everything sort of automated to come up in the same way, but nothing is ready. Now, the downtime that you're going to suffer here is mainly going to be moving the database information and maybe some application data, and you also have to restart your servers and possibly do a little testing. So that's why it's going to take you a little bit of time. So this could be, in the media example, it could be some kind of game, a mini site that's not really sponsored, or it's not your core thing. It's just something you provide for entertainment. Now, in this next case is the multi-region warm DR. The main difference here, again, we're in the two different zones, Chicago and Dallas, but this time you'll notice Dallas has a slave database that's live replicating, and so that way you skip out on this downtime that you might spend moving data across because it's hot. And now all you have to do is bring up your app servers, bring up your load balancers, and you can turn on the site again fairly quickly into the Dallas zone without necessarily spending all that application server money or load balancer money while it's not doing anything. So then we move over to the multi-region hot DR. This one, is like I can say, it's really great, but you'd be burning a lot of money. If you're a bank, it might make sense here. So you have everything. You'll notice the Dallas region this time, the load balancers are running, the application servers are running, the slave DB is running, but it's not taking live traffic. So you'll notice the dotted line to DNS there, so it's not connected. So if Chicago region were to go down here, you could just basically flip DNS and run it all out of Dallas, and you wouldn't skip much of a beat there. And I guess I will pass it on to Brian now to talk about the HA options.
Great, thanks very much, Roberto. And while Roberto was talking there, I was taking a quick look at some of the questions that have been coming in, so thank you very much for those. I'm not going to jump in and answer them right now because let me kind of get through their content, but those of you that are submitting them, please do know that I've taken a look and I've got some answers for you, so I'll get those to you at the end here. There's some stuff that I don't think necessarily ties directly into the content we're on right now, but they're still darn good questions, so we'll make sure we address those at the end. What I do want to talk about right now is multi-cloud high availability. And this is what a lot of our customers come to us asking for and say, hey, this is really what I want. I want to be running my application in two entirely different regions or two entirely different clouds. For example, you see here Amazon US East and CloudStack in Chicago, right? Or this could be Rackspace in UK or whatever it may be. They're saying, hey, that's really, really what I want. This is definitely possible. We do not recommend it. In the next slide or two, we'll kind of talk a little bit about that. It has the maximum additional cost, right? You've got everything running everywhere. You've got traffic egressing to the public internet that you're charged for, and it's complex to implement. It's complex to manage. Now, with that said, do we have any customers that are currently doing this? Not currently. We've had some folks that have done this, and then they realized that, hey, it was quite costly and quite complex to manage, and it was overkill for their particular needs. We've also had some customers that have done it as a proof of concept to show to their upper management that, yes, hey, this can be done. And then it was torn down. But currently in production, not a lot of folks use a scenario such as this because of the cost and complexity that we're going to talk about here in a moment. Okay, so it looks kind of similar to multi-zone, right? If you just kind of made that on the left US East 1A and over there on the right US East 1B, it looked really similar, right? But it's very different because resources aren't shared across regions or across obviously different cloud providers. So you need DNS management, right? You need some sort of geolocating DNS service that's directing traffic based on geolocation of your end users. If you have folks that are close to US East, you want to send them to US East. If you have folks that are closer to, well, in this case it's Chicago, but maybe it was US West or whatever it might be, you want to send end users that direction. That's not a must-have, but obviously from a latency and an end user perspective and their sort of happy end user experience, that's going to be definitely desirable, right? So you need some sort of service to handle that. The machine images are specific to the cloud in the region, right? For those of you that are running in AWS, you have an AMI that's in US East. You don't have that exact same AMI in US West. Now, granted, this morning Amazon did announce, like I said, the snapshot copy option, and they're going to be following on that eventually with the ability to move those AMIs, but currently you don't have that ability. We'll talk a little bit at the end of this section as well, where RightScale kind of currently provides you that with what we call our MCIs, or our multi-cloud images. The big issue, two big issues that I really see is, one is it's complex to set up, but the other is security, right? You've got to worry about the security as you go from region to region, because you're egressing to the public internet at this point, and you're, that traffic is therefore out there where the bad guys can sniff those packets if they want to, right? So you need to secure that traffic as it goes from region to region. And also you're going to be paying for that bandwidth, right? Inter-region, right, bandwidth, like for example in US East from 1A to 1B, is charged at like a penny a gigabyte or something like that. It's nominal charge, but if you're leaving from going from region to region, that can get a lot more expensive because it's charged on a sliding scale. So for those of you that aren't familiar with RightScale, I know that we took a look at the folks that are attending. A lot of you are RightScale customers, so thank you for that, and others are probably just taking a look. But for those of you that aren't familiar with the dashboard, what we've got here is sort of a view of a warm DR scenario that we have created and we have currently running in the dash. It's a very simple one. It's got a very small number of servers. It's really just done as a sales kind of demo environment, but it's at least representative of the concepts that we're talking about here today. You'll see that it is multi-region. We've got servers running in both US East and US West. You see that that little box there highlights where a multi-region warm DR slave server is, right? All the servers above that, the master, the slave, and the two front ends are running in AWS US East, whereas that single slave that you see there is running in US West, and it's replicating from that from that master in US East. And then you see our stage servers down here. These are servers that are in US West that are ready to be launched. As Roberto was talking about, you have those servers that are sort of in that stage environment that they're not running, so they're not incurring any costs. And if something catastrophic was to happen to US East, we can go ahead and promote that slave database to a master and launch those two stage servers and get the DNS configured to point to our new front ends, and we'd be up and running in relatively short order. What we also provide is cost forecasting. So you can see up here in the upper right the cost forecasting for both the primary environment and the DR environment. Now granted, what you see here, because we're using such a simple example where we only have 3 servers in the primary environment and we have 1 in the DR environment, obviously the DR environment is a third of the cost, which sounds quite a bit. In a real environment, it would be a fraction of this, right? Again, this is just for these simple demo purposes that we have this set up like this. So how do we automate this HA and DR stuff, right? Which parts should we automate and which parts shouldn't? And the parts that we should, how do we do it, right? Well, we always recommend you use dynamic DNS for your database servers, right? That'll allow your app servers to always connect to their database using a single fully qualified domain name, right? They can always look for mymaster@mydomain.com, and if the master changes, if a slave gets promoted, use dynamic DNS to do that flipping of the A records behind the scenes, so the app servers never need to know. They always go to that same FQDN to find their master database. We recommend use a low TTL on those records as well, so that if you do need to promote that slave to master, the downtime between the promotion, the downtime that your app servers will experience while they're trying to find that new master will be minimal, right? Basically, when that TTL expires, they'll have to do a new re-resolve on that FQDN to get that new IP that has been swapped out behind the scenes. We recommend you automate the connection of your app servers to your load balancing servers. When those load balancing servers fire up, when those application servers fire up, they should be able to connect automatically to all of the load balancers, be it you have 1, 2, or 10, however many you have, and you want to have that happen automatically at launch. You don't want to have any manual intervention, and you don't want to have to do any DNS modifications, nothing where manual error can occur, right? Because these things aren't going to fail at 10 a.m. after you've had your cup of coffee. These are going to fail at 2 or 3 in the morning where you have to do things quickly, and you want to make sure your automation is going to be error-prone as opposed to relying on yourself to be to not make any errors. And then the automated promotion of slave to master. We always recommend to our customers that the process is automated, but the decision to run that process is manual. Once you've pushed that button, there ain't no going back, right? So you want to make sure that, hey, I really want to do this promotion, and it's not some other problem that's manifesting, that appears to be manifesting itself as a database problem, right? We've had customers in the past that have done this themselves and have automated this process and tried to use certain metrics, and it's ended up biting them because the promotion happened in a case where the master wasn't actually down. There was network issues, there were some other issues that were causing problems, and it resulted in some, not necessarily corrupted databases, but some manual reconfiguration of tables and things like that. So again, we always recommend that you automate the process, but the decision, you push the button manually to go ahead and kick off that process. So a little bit on how RightScale makes it possible for those folks that aren't RightScale customers currently. I mentioned briefly the MCI concept, or the MultiCloud Image concept. The MultiCloud Image, basically I'll kind of walk through these and talk a little bit about it in more detail, but the server template, which we'll talk about here in a second, we maybe should have done these in different order, but the server template contains a list of multi-cloud images. And those are things like CentOS 6.2, Ubuntu 12.04, Red Hat version 5.5, whatever it might be. When a server is created, you choose a specific MCI. Hey, I want this application server to run on CentOS 6.3. And then when that server is launched, the appropriate underlying write image, we have a CentOS 6.3 image for each of the regions and each of the clouds that we support, so that when you go ahead and launch that server, we will automatically select the correct write image for you underneath. And if you launch a CentOS 6.3 in US West and you launch a CentOS 6.3 in Rackspace, that's going to be the basic same flavor of OS with the same packages. You do a PS, you're going to see the same processes running. You do an LS, you're going to see the same files in existence. We've taken care of that abstraction for you. And by using that MCI, that sort of umbrella that rides on top of those underlying write images, you don't need to worry about selecting the individual image you want, just the flavor that you want, and we'll go ahead and choose the specific one for you. And now on the server templates and tags and inputs, on this page we'll talk a little bit about it, but this does things like auto-scaling across zones and does our dynamic configuration, things like that. What you see in the lower left here is sort of a list of boot scripts. This one actually is Chef recipes. We support both a scripting mechanism, using Bash or Perl or Python, whatever it may be, and also Chef. And this one happens to be Chef. But what this is showing is sort of the boot sequence, if you will, of all the stuff that needs to be run on this server in this order as we go through the process. So using this concept of a server template where you specify the packages and software that needs to be installed and the order it needs to be installed in, and then in concert with the inputs, which you see over here on the right, where, for example, this is for the DNS, right? You can set the DNS provider. You can say, hey, I want to use DNS Meet Easy, or I want to use Route 53 from AWS, or I want to use Cloud DNS from Rackspace, whatever it may be. You provide your credentials there, and you can go ahead and this way, this will automatically take care of that DNS configuration for you. So with the combination of the RightScale multi-cloud images and then the server templates riding on top of that, we sort of have taken care of that abstraction and also the automation and dynamic configuration of those servers. What we've tried to show here is a little bit of a quick DR cost comparison, because folks are always curious to know how much is this going to cost me, and obviously the reason that cold DR is so popular is, well, it's free, right? It doesn't cost you anything. But RightScale has a tool called Plan for Cloud. It was a company we acquired a little while back. I think they were called Shop for Cloud at the time. And you guys can go to planforcloud.com and you can go ahead and play around with some of the stuff on your own. But what we've done here is kind of giving you a very simple scenario, right? Let's say that in you have 3 load balancers, 6 app servers, 1 master and 1 slave. So you see that, for example, in the multi-region cold DR. What your current run rate is going to be about $4,480 a month with these assumptions that we've made. You notice that in your staged environment, you're not costing you anything because nothing's running, right? You've got this other environment that's in this staged, non-operational state, and we assume that you're replicating data from one region to the other. You have a very busy database. You got 25 gigabytes a day going across cross-zone, I guess, in this case, obviously, because we don't have another region set up. The multi-region warm DR, it's very similar. The only difference there being is if you notice that you have 2 slave databases running, right? And you have that second slave running in that other region. And now you have the cost of the data being replicated across region, and that bumps it up to 90. And then the multi-region hot DR, you'll see that that's the maximum cost, right? You're running there at about $8,800 a month. You've got all these servers running in another environment, and all that you've really gained in this, as Roberto was talking about, is the ability to get yourself back up and running more quickly because the servers are already running and you don't have to wait for them to boot. So hopefully this in concert with what we discussed before will show you why we generally recommend a multi-region warm DR for our customers that are looking for a DR solution. And again, if you want to go ahead and experiment with this yourself, please feel free to hit up Plan for Cloud, and you can go ahead and enter the sort of unique characteristics of your application, or even guesses at how you're going to have things architected, and see what your run rates are going to be. Okay, most common observed cloud outage. What have we seen and how has it affected people, right? So we've seen outages of specific services in a specific zone, right? And for example, like EBS and ELB and RDS. And what results there is you get degraded performance within that zone, right? We've also seen outages of specific services in a region. So for example, the EBS outage of April 2011 was seen across all of AWS US East. It actually started in one zone, but because of cascading effects, it ended up affecting the entire region as a result. You can have outage of power or network in a zone, right? And now you've lost your connectivity, and EC2 and both EC2 and Azure have experienced this in short bursts in the past. And then the capacity availability. During an outage in a region, right, folks are going to be scrambling to get their servers running somewhere else, right? And as a result, there might be capacity constraints that you're going to hit where you can't provision your instances, you can't create volumes, things like that. We'll talk a little bit about that in a minute here about how you can mitigate around that. As you might expect, the way to mitigate around it is to spend more money, but there are options, I guess is the point. So sort of in summary here before we kind of jump into some of the questions and whatnot, some of the outage proofing best practices that we talk to customers about. First column, resource placement. Where should I put my stuff, right? Well, we always recommend you place in at least 2 or more zones one of each of these tier, or every tier of your application. So you want to have load balancers in at least 2 zones. You want to have your app servers in at least 2 zones. You want to have your databases, your master in one zone, your slave in another, right? You want to spread that architecture around so that if you happen to lose a zone, you haven't lost everything, right? You want to keep that fault tolerance high and eliminate that single point of failure. If possible, and this is where it gets a little expensive, maintain capacity to absorb zone or region failures. So for example, Netflix is famous for doing this. They over-provision the servers they need. They're actually underutilized, and they do that intentionally so that if a zone goes down, the servers they currently have running in the other zones can handle their entire load. Now, again, that's a luxury that they have because they probably have a little deeper pockets than some, but there are options out there, and this is one of them. Second column, replication and failover, right? We've talked about this. Replicate your data across the zones. Put that master in one, put that slave in another, and make sure that you replicate that data. And that goes not just for your master and slave databases, right? That goes for shared file systems you may have. Whatever data you have, make sure it's not just in the single zone. For backups, you want to do those backups across regions and or clouds, right? For a DR scenario, you want to have that data somewhere far, far away, so if something bad happens in your primary environment, you have your data. And you want to set up monitoring, alerting, and automation, right? You want to find problems before they become problems. So use monitoring and use alerting. Put monitoring on your databases. Put monitoring on your app servers, on your load balancers, everywhere. And have thresholds set so that you're alerted when certain conditions are met so you can take a look. Try to find the little problems before they become big problems. Excuse me. And then the last column here is application design. Right, you want to replicate data across the zones. Again, we've heard this multiple times. And like I said, this doesn't go just for the master and slave or just for your database tier. It goes for any data you have, shared file systems, etc. And where possible, you want to design your apps to be stateless, right? So they're resilient to reboot or relaunch or accidental termination or a zone disappearing. So for example, if you're using sticky sessions, that's all well and good, and your users are going to be directed to the same app server. But what if that app server goes away, right? There's definitely going to be a hiccup in the end user experience. If you can store that session info somewhere else, be it in a database or even better in a memcache or a similar caching tier, you're going to be able to survive the loss of that app server, and that end user is not really even going to notice. So again, kind of try to think about how you can segment and remove the tight coupling, if you will, in your application to give yourself more resilience and eliminate any single point of failures. So next steps before we jump into the Q&A, a lot of this information that we've talked about here is available in the white paper you see here. We also have a generic white paper section of the site that has a lot more info on a lot of other topics as well, but the one we've called out here in particular has a lot of this detail in a little bit more depth, if you will. Also, if you want, you can get a deployment review of your environment, and if you're a RightScale customer or even not a RightScale customer, Roberto's group, the Cloud Solutions Engineers, will be glad to talk to you guys on the phone, looking at your deployment if you're a RightScale customer, or at least talking about what you guys have or planning on having if you're not, and trying to talk to you a little bit about where are you positioned from an HA and DR standpoint. And then lastly, this is the free edition. RightScale.com/free, as you can see here, you can sign up for, I believe it's a 60-day trial, and you can get all the features of RightScale for that 60 days and be able to kind of kick the tires on all these different things and see how these bits and pieces work. So with that said, that sort of wraps up the content portion that we have today. So now I'm going to jump into the Q&A, and we've got this Google Doc here in front of me. Let me take a quick look and see what we can pull out and answer a few of these here. So someone says, do you have suggestions, this is a good one, do you have suggestions for detecting and recovering from EBS failures? Yeah, I know I should take snapshots, but how does one distinguish an EBS failure from an EC2 failure and deal with it? And that's a real good question, and that's based on, obviously, this person has probably suffered one of those outages that we've discussed, and that, as I mentioned earlier, a lot of the AWS outages were EBS primarily or solely, right? And as such, you know, how do you monitor this EBS backplane? How do you monitor EBS to know if that's the problem or if something else is the problem? Well, we've played around with this a lot ourselves. You know, I wish there was a better phrase, but eat our own dog food or whatever it is, right? We do all this stuff ourselves to run our own site. So we're trying to find ways to find these things out earlier as well. We also have some contacts in the AWS organization that we've reached out to also, and the answer is there is no real good answer. It's really tough because a lot of these services are coupled. For example, for those of you who were experiencing the most recent outage, RDS and ELB, right? You're like, ELB, why would a load balancer be affected by EBS? Well, it was because a lot of its configuration information was stored on EBS. So it's tough to really find out how do I know if EBS is the problem or not. But one thing that we have been experimenting with, and you might want to as well, we basically have, it's not real elegant, but we have a cron job running that's go ahead and it's writing a file to an EBS volume, and we're basically monitoring the return time from that write, and we're plotting it over time, and we have a pretty good idea of what an average write time is. And when we see that write time exceeds some certain threshold, we say, something's up here, it's worth at least looking at. It's not a foolproof method by any means, and the other issue is that we've only been able to really use it once because EBS outages don't happen that often, so it's not something we can test. So, you know, not that we want an EBS outage to happen, but we have it running, and the next time it happens, we're going to look at our data. But unfortunately, it's about the best that we can suggest right now because there are no real good tools to sort of figure out, is it the EBS backplane that's having a problem or if it's something else, if you will. All right, so the next one says, the presentation so far has been about standard web apps. That's true, right? We've been talking about stuff that have a front end, an app tier, and a database. And this question is, what about HA and DR for more complex apps in which you not only have front end, but also multiple web servers interacting with each other? Well, the answer is the concepts are the same, right? I mean, really what we always recommend, and we didn't necessarily talk about it here because it was more about outage proofing, but from a scalable application standpoint is isolate your tiers, right? You want to make sure that you keep each of your web services is in its own tier of servers, and therefore you have created some loosely coupled architecture, and therefore you can scale each of those independently, right? If you have a bunch of services running on a single server and that server is experiencing a problem, multiple services are going to be affected when maybe only one of them is really the problem, right? So kind of loosely couple yourself and use the same concept we've talked about. Spread them across AZs. If they're having persistent data, have them replicate to another region or another cloud altogether. So the concepts are the same. You know, we've just used kind of simplified diagrams to keep it simple, but really what we've discussed here works for regardless of the architecture. It works for any of the type of application architectures that you may implement.
Sure. So I noticed one of the questions here, I'd like to hear something about DNS alternatives to multi-region, multi-cloud setups. So especially on the multi-cloud setup, you wouldn't want to use a cloud-specific DNS service, like Route 53, let's say. You'd really want to use an external DNS service. And so one example would be like Dyn DNS. They have a couple nice features that I liked, and I've used them before for multiple projects. And one of them is this ability to dynamically update the entries is really key for this kind of automated configuration. And the second one is, sorry, maybe there's three. The second one is they can do a health check basically on the back-end IPs for each of the, let's say, A records. And so it can actually take IPs out if the health check fails. So that's a real nice thing to have up front. If you have two clouds, then it could actually take out a cloud. So your DNS entries that are user-facing don't necessarily have to have a super low TTL because it'll take them out of that pool based on if the health check fails or not in that case. And then thirdly, it's just as geographic, it's sort of geo-IP, so that way you can get your customers or whatever the clients are as close as possible to the cloud in question here.
Cool. Yep. Thank you, Roberto. Yeah, I was just scrolling through. Sorry, I was just scrolling through the list while Roberto was talking, and actually, I'm looking at some of the pre-submitted ones as well, and I want to make sure we address those also because we might not have touched on those in exact detail. But one of the ones that someone asked is they said, is it possible to have a number of backup instances for the situation in which we have dramatic increase of volume of demand from our users? In other words, can we have some stop instances that can be started without significant delay? So that sort of ties more into auto-scaling and sort of dynamic response to load as opposed to outage proofing, but it's still sort of relevant to what we're talking about here. Is that for those of you who aren't familiar with RightScale and the RightScale platform, we have what's called the server array. And the server array, it's sort of a short version of it. It's servers that all look and feel alike, and you can set a minimum and a maximum on that array. And you can also set alerts on those arrays such that it will grow and shrink based on certain metrics that you have created. So that's a classic use case of RightScale. Is go ahead and set it up. Hey, I'm expecting some viral event. We used to call it the Oprah effect back when Oprah was on the air. Some customer would have their product mentioned on Oprah, and their site would get hammered, right? So what they would do is they would set up an auto-scaling array such that when certain metrics are met, CPU was busy, or free memory went down, or Apache connections went up, or whatever it might be, we would go ahead and spin up additional instances for you. Generally, we don't recommend that you have stop servers that you go ahead and start. We generally recommend that you just launch additional ones. If the launch time for those servers is dramatically long because you're installing big packages or you have a lot of stuff you need to download, then you can always bundle those images and create sort of bundled write images. We don't recommend that, again, because if you ever need to change one bit on those images, you've got to go ahead and rebundle again. But the point being is that, yes, we definitely have the tools in place in the RightScale platform to allow you to auto-scale up and auto-scale down based on the demand that your system is seeing.
One thing on that, Brian, I wanted to mention is a couple of things are just design level things. One is putting some kind of caching server up front of your applications, something like an AI cache or even a varnish server. We've seen a lot of times, especially when people have sub-second spikes, or you have 100,000 requests per second, you can actually cache things for really short times, even 1 second, 2 seconds, whatever your application can handle without having a stale data problem. And if you do that sort of thing up front, you really offload a lot of that hit to your back ends, and that gives you a little time to ramp up your application, and not necessarily have it linearly correlate to exactly how many hits you get on the site, but it's a nice decoupling, sometimes 10 or 100x decoupling there.
Great, thanks, Roberto. And then another question here is, it says, is there a rule of thumb for the number of resource outages or length of outage before promoting a slave to master or for migrating to another region? That sort of ties in with that one slide a couple back where I said that you should have the process should be automated, but the decision should be manual, right? Because it really depends. There's so many ways for a database to fail, right? You might think that a database failed when really it was internet connectivity, or you might think a database failed when really the tool that you were using to monitor had a problem, right? You've got to watch the watchers or whatever it might be. So generally what we have our customers, what we look at, and we recommend to our customers as well, is that you look at the seconds that the slave is behind the master, right? You can replicate, so you can go ahead and look and see. And if you see that value starting to go up, that means that slave obviously can't get to the master. Something funky is going on. And it's probably worth taking a look and seeing what the issues are. Now, granted, you can also set up alerts on your master databases when certain CPU thresholds are hit, right? When we see master databases thrashing, it's typically because their I/O wait, right? They're trying to scribble to the disk really, really fast, and they can't keep up. And you'll see this big spike of red on our graph, which is an I/O wait. So people can put a watch on that particular CPU usage, and when it crosses some threshold, at least take a look. And that kind of goes into what I was talking about, is find little problems before they become big problems and try to act on them accordingly. So as far as a rule of thumb, no. I mean, it really is put some monitoring in place, and when those thresholds are crossed, take a look and see what the heck is going on. And as far as migrating to another region, well, obviously that's if the entire region that you are trying to run in, you just can't get the instances or can't get the volumes or can't get the resources that you need. The DR scenario really should just be used for a catastrophic event where you cannot get any other resources, or the resources are just not available in the region that you're currently running in.
One small thing to add there is I highly recommend that people characterize their application, so run a medium-sized load test and actually drop the database and see what fails and what happens. And do the same, start up a database without any BS volume, see what happens, and you'll start to get an idea of what alerts you should really watch. And so that really helps in terms of, don't wait for the failure to happen, pre-test and figure out what you need to do beforehand.
And another question that I was digging through the ones from last night just to make sure that we address ones that weren't covered in the content. And it says, should we be afraid of cloud services closing in the future? Nothing is permanent. And that's a real good point, right? I mean, obviously, you know, there's some 800-pound gorillas out there, and then there's some other players that are up and coming, and who knows what the future landscape is going to hold, right? And that's why it makes sense to try to use cloud portable solutions, right? So, for example, what we generally recommend to our customers, and we didn't talk about it here today because it wasn't really about that topic, but what we'll recommend to our customers is don't use vendor lock-in stuff, right? You know, don't use a load balancing solution that only works in one cloud or a database solution that only works in one cloud because, A, if you ever have an outage in that cloud and you need to move to another, that's going to be difficult. B, if the pricing in another cloud all of a sudden looks attractive, but you're totally tied to that first cloud because you're using all their integrated services, that's a problem. And then to this point here is that if that cloud provider goes away for whatever reason, right, you want to have cloud portability so that you can go ahead and, you know, pack your stuff and move somewhere else. So yes, you absolutely have to think about cloud providers potentially going away in the future. And that's why cloud portable solutions, things that don't use vendor lock-in, and then little RightScale plug here, you know, use a RightScale platform that's sort of cloud agnostic and allow you to move your stuff from one to the other is definitely a recommended solution.
So one unique thing with, you know, that's pretty new to DR is actually you could, let's say if you design everything on RightScale, you could move to a cloud you have never been on, you know, relatively easily. Try to do that before with just straight data centers. You know, that would be, you know, it could take you weeks to months to actually move something, whereas in this case it could be, you know, half a day and you could be up and running again on something you'd never been on before.
Another question I see here is, and I make sure I understand it right, hopefully I'll answer it as it was intended, but can you address the latency issues for HA rather than outages? So I can talk at length about AWS here and a little bit less experience with Google and Azure because I'm just starting to play around with those guys. And then Rackspace is a little different because their regions are disparate regions, if you will, right? Their ORD, their Chicago region and their Dallas region, you have to egress to the public internet in order to get from one to the other. So latency there is extremely unpredictable, right? You're kind of at the realm of the public internet, and you know, if there's a storm in Chicago, your data's got to hop around until it finds its way to Dallas, that kind of thing. But latency issues within AWS, for example, if you set yourself up in a single region, for example, I'll use US East because that's the vast majority of their customers are in US East, and most of my testing is taking place there as well. But in US East 1A and 1B, C, D, and E, right? If you go ahead and do ping tests, for example, from one zone to another, so A to B, you'll see that generally under 2 milliseconds. And within the same zone, A to A, you'll see like 500 microseconds. So the latency that you will see within those regions is generally extremely low. And therefore, it makes it very, very attractive to go ahead and set up an HA in a multi-region environment because you do have that very fast response time and that very low latency. Now, once you go cross-region and cross-cloud, like I said, you're on the public internet and all bets are off. But typically, if you're in with that single region, you're going to see sub 5, and like I said, most of my tests have been sub 2 milliseconds from server to server between zones.
See one here, are there any issues specific to RDS connectivity that make HR and DR difficult? So probably the biggest issue we've seen with RDS is that at the moment there is no cross-region. Yeah.
Correct.
Yeah.
Correct.
So there's no cross-region. So if you really want, let's say, HA across regions or DR, then you're going to have to roll your own little bit. We have some standard MySQL templates that can do that across now. And then the other, I guess, thing I would say is when you start using cloud-specific features like RDS, ELB, all those things, which are fantastic. But if you want true multi-cloud HA or DR, then those things don't always carry across. So that's why if we have customers that really are interested in multi-cloud, then we will definitely suggest using some of our templates that are portable across those different clouds.
Yeah, exactly. And more to Roberto's point is that, for those of you that have used RDS, you're probably familiar. They have sort of the standard. I don't know. I think they call it standard. I'm not sure. And then they have the multi-AZ RDS, right? And multi-AZ, as the name implies, is that you have a multi-availability zone RDS. And that's within that single region again. So you're still locked to that region, and your data resides in that region. You cannot, with RDS, currently set up a replicating slave in another region. You just can't do it. So if you lose, if you're in US East and all of US East goes down and you're based solely on RDS, you're kind of, I won't say out of luck, but you kind of have to wait until that RDS service comes back up before you can get yourself back up and running. And that kind of goes into that vendor lock-in thing that I was just kind of alluding to in the previous discussion as well. The other thing about that, and we've had customers, and I don't want to sway you off of RDS, it's a wonderful tool and it works great, but if you ever do need to get off it, the similar problem there exists. Since you can't have a replicating slave based off of it, you've basically got to shut things down, do a dump, and then do an import in another environment and get yourself back up and running. So these are all things you need to think about from both an HA, but more importantly a DR. If something bad was to happen, it is currently a little bit difficult to get yourself back up and running if you were based on RDS. Let's see. Sorry, I'm going to scroll through the ones from last night. I had a few others I wanted to address. So this question is, how critical is the role of a multi-cloud solution as opposed to AWS only in outage proofing? How is the solution affected by the use of multi-cloud in terms of ability to use the cloud-specific features? And that kind of all ties into what we just talked about, right? The AWS regions are very isolated, right? US East and US West, they don't share any resources, they don't share any power, they don't share any network or cooling or things like that. So if you're comfortable in AWS and want to remain there, then that's fine. It probably does always make sense, at least to entertain the idea of setting yourself up in another cloud if, as we talked about before, I don't think AWS isn't going anywhere. They're doing a great job, but maybe there's a better pricing model somewhere else, or maybe a cloud opens up that's much closer to your end user base and latency is greatly reduced, or maybe there's some niche cloud that comes out with some offering that's really attractive to you. There's other clouds out there, for example, like Rackspace has something called Rack Connect, for those of you who aren't familiar with, where you can have your cloud servers can have a dedicated link, or a direct link to your dedicated hardware. So you can have physical hardware running your databases and pay for whatever beefy hardware you want and still have cloud servers have access to them. Currently, you can't really do that in AWS, right? And that's not their niche, and that's fine. Software has what they call, well, I'm not sure what they call it, but I call it their worldwide LAN, where basically any of their regions anywhere in the world have sub 40 millisecond latency to every other one. So, and they're all in the same 10.x network. So maybe if you wanted to set up a global game and you needed to have all your users in that same environment and have very low latency, software might be interesting to you. So really take a look at what your needs are and what the options are. I mean, it's like with anything, like buying your car, the same things, right? What do I need and what options do you got and how much am I willing to pay? Because the offerings are they're all different. They have a lot of things in common, but they also have a lot of uniqueness. And it really does make sense to kind of shop around and find the right fit. The right fit's probably out there. You just got to go looking for it. Okay. Sorry, Roberto, do we have any others? I'm trying to take a look here real quick. What else we got? Okay, so this here question is, what do you recommend? This is a very timely one. Someone must have been bitten again by the recent one. But what do you recommend to mitigate against API flooding and resource contention in a DR region in the case of a primary region failure? And that question is probably related to the most recent AWS outage. And what AWS did, and they acknowledged that they maybe overdid, is that with their previous outages, they realized, hey, when something goes down and people start to notice that, they want to go ahead and spin up additional servers to compensate for that. And everybody does it at the same time. And as a result, our API endpoints get flooded and, we can't handle this. And so it turns into this cascading failure. So what they've done is they've done a little bit of API throttling. And basically, I don't know their metrics, but basically different accounts were throttled to being able to make API calls at a certain rate. And they over-throttled. And by their own admission, they over-throttled. And that's something they'll learn from and they won't do again. But how do you work around that? That is a very difficult one to work around. And so what we generally would recommend in that case is, again, the answer is going to be it costs you, right? But the Netflix model, right, where you have capacity to handle if you lose a zone or whatever it is you've lost. You have servers already running that can pick up that capacity, which means they are intentionally underutilized and you're paying for stuff you're not currently using. But if your API calls are being throttled, there's really not a whole lot else you can do other than to rely on what get the most blood out of the turnips you've got, because you can't add any more turnips at the time, if you will.
One thing that I might mention too is that let's say in the Amazon case, each one of the regions has different API endpoints. So, and they're completely independent. So, let's say if you're trying to do HA just using availability zones, those are sharing kind of the API entry point there. So if it's an API flooding issue, it might be best to just ramp up, and if you were in US East to go do it in US West. So that could mitigate some of that region flooding issues.
Mm-hmm. Mm-hmm. Okay, and then I'm digging into last night's questions as well. So someone said, how efficient is the infrastructure as a service platform nowadays compared to a dedicated server environment when it comes to offering matching computing unit offerings? And the answer really is you're always going to be able to find dedicated hardware that's faster than cloud-based hardware, right? It's a virtualized environment. You're going through at least 2 network stacks, so you're always going to be able to find dedicated hardware that is faster if you're willing to pay for it. But with that said, the cloud providers provide a pretty wide offering, a pretty wide menu of instance sizes that are out there. For example, AWS at reInvent last month introduced an instance that has 240 gigabytes of memory available. It has and another one that has 48 terabytes of disk space. That's pretty impressive. Now, can you find something out there that's bigger? Yeah, it's extremely expensive, and where else can you get it for $3 or $4 an hour or whatever they're charging? So, if you're really looking at speed of light matters to you, and you've got to fine tune things down to the nuts and bolts, you're always going to find dedicated hardware that's going to be faster. But there are a lot of offerings out there, and there's more being added pretty much every day to the different vendors. So it probably makes sense to look at your options, figure out what your needs are, look at the options, and you probably can find a fit for it out there.
I also wanted to add that a lot of times applications have been designed with that kind of fast hardware in mind, but you can also attack the problem with, like we mentioned a little bit, with caching, things like memcache. So you can deal a lot with some of the requirements basically by doing really smart caching and making that part of your solution too.
Got it. And I think, sorry, we got time for a few more? Mm-hmm. Okay, so getting the thumbs up, we got time for a few more questions. They're still coming in. So the one I see here is DNS TTLs are not honored by all DNS cache servers, even if you set it to a low value. Have you seen this? And if yes, what's the alternate solution? Well, where we really see that is in Internet Explorer, to be honest with you. For those of you that have felt through that pain, Internet Explorer basically ignores your TTLs and puts everything to 30 minutes. If it's greater than 30 minutes, it'll honor it. But if it's less than 30 minutes, it puts it at 30 minutes. So for front-end stuff, for example, that your users are going to be hitting from a web browser, we always recommend try to use static fixed IPs. So for those of you that are familiar with Amazon's offering, the EIP or the Elastic IP, we always recommend you use that. That way you can register your DNS record for your front end. www.mydomain.com has an IP, or if you have 2 of them, 2 IPs, whatever it may be, and those don't change. Maybe the servers behind the scenes that are actually attached to those IPs change, but that doesn't matter. Your end user is always presented, when they resolve, they always resolve to the same IP, and that gets around that caching issue from the front end. Now, we recommend using the low TTLs for the internal components, for example, the databases, right? And the database resolvers there are usually the Linux or Windows tools that you're using on those instances. So, for example, if you're running on MySQL on Linux, it's going to use the built-in, whatever OS you're on, it's going to use the DNS resolver for that, which generally do respect those TTLs. And really, that's probably the best way to get around that is use for what's the word I'm looking for, user-facing, public-facing endpoints, try to use those fixed static IPs. For stuff that's internal, you can go ahead and use those dynamic DNS solutions with low TTLs because they will be honored by the Linux or Windows tools that you're using and not the browser tools that your end users are using. Let's see here. Sorry, folks, I'm just kind of reading through again and see if there's anything else here. Hopefully this was discussed in the webinar. There are a lot of tools for failover within a cloud region, i.e. between zones, but how do you accomplish failover between regions for true DR? Hopefully we talked a little bit about that, particularly in the warm DR scenario that Roberto mentioned. The one thing that I did want to mention that we didn't discuss, and maybe we probably should have now in hindsight, is that we talked about the security of that aspect of that, right? You've got your data going from your master across the public internet to your slave running in the other region. We said you have to secure that, right? Well, you don't have to. Obviously, you should. But there are multiple options there, right? So for those who are familiar with MySQL and Postgres, they both have a built-in SSL replication feature, and we have customers that are using that. So basically, they're using the built-in, using self-signed certificates between their master and slave running in these different regions, and they're encrypting that traffic themselves. There are other options out there. One of our partners, I'll give a little plug for them. The partner is Cloud Opt, and the product is Cloud Optimizer. and that allows you to do both WAN compression as well as point-to-point encryption. So basically it intercepts stuff down at sort of the IP tables level, if you will, and you give it the public IP of your slave and master, and any traffic that travels between that public slave and that public, the public IP of the master and the public IP of the slave is encrypted and sent across and decrypted on the other side, as well as being compressed. So not only are you getting it encrypted, you're also getting it at a little lower cost because your bandwidth is going to be decreased as well. I think that's pretty much all of them. I'm seeing if there's any more questions that have come in. I'm looking at Ryan and Sarah to see if anything else has come in before we let you guys go. One sec, let me see. Something else just popped in here real quick. Make sure that I didn't already discuss it in the webinar. Can you please discuss alternate methods for rapidly and seamlessly redirecting web traffic from one cloud location or provider to another? Well, that's where the tricky bit comes in, and that's where the low, as low as you can, TTLs on that. Everything that I just said, well, this kind of violates that, right? You want to have those static IPs on your front ends, right? But if something real bad happens, you need to move to another environment. EIPs don't cross regions, and EIPs definitely don't cross cloud providers, right? So you want to have reasonable DNS, you want to have reasonable TTLs. We generally set our stuff at 5 minutes, and if the browser doesn't support it, the browser doesn't support it. And if something bad happens, you need to go ahead and make those modifications, manual or otherwise, to your public-facing DNS record so that it'll redirect traffic to the new environment that you have. Now, the worst case, and this is a bad case, granted, but the worst case is that you'll have about 30 minutes where those Internet Explorer users are using the old IP until eventually the cache expires and they go ahead and do a re-resolve and get the new IP. But that's generally what we recommend to our customers as well.
One small caveat on that one is if you're moving because of an EBS failure, you could actually have your kind of front-end load balancing servers redirect traffic over to your other region or zone, and so you wouldn't necessarily have to have a TTL fix. You're just basically still accepting that EIP, but sending the traffic over to the region that you know is working, let's say, if it is just a storage issue.
Yep. Yep. All right, and with that said, it looks like we're just about out of time, and that was kind of the last question that we had teed up. So I'm going to hand it back over to Sarah for our little wrap-up, and Roberto and I would just like to thank you very much for spending the last hour or so with us.
Thank you.
Yeah, and thank you so much, Brian and Roberto, too, for your time and sharing your brilliance with the rest of us. That's it for today's webinar. Thank you for everyone in our audience for joining us today. This webinar has been recorded. Once we close this out, we'll just compress it, create a video file, and send it out to you guys. So tomorrow morning, if you'd like to relive the magic or share with your friends and colleagues, you'll be able to do that. Thanks again, everyone. Enjoy your holiday season and have a great rest of your day.